Welcome to our next Year 7 Maths video related to equivalent fractions. So equivalent fractions have the same numerical value, and an equivalent fraction can be formed by multiplying both the numerator and the denominator of a fraction by the same value. So on the side here we have an example. So we have 4 over 5, and basically you can see that we've multiplied our top number by 3, which gives us 12, and our bottom number, or our denominator, by 3, which gives us 15. So 12 over 15 is equivalent to 4 over 5. So by multiplying top and bottom by 3, we were able to form this equivalent fraction, and we'll go through an example very shortly showing that. And the same can be done by dividing a numerator and denominator by the same number to produce an equivalent fraction. And again, I'll go through an example to show you how to do that. So, working from the textbook, example 2b1, it asks us to fill in the gap to make an equivalent fraction. So, I have 2 over 3, and they've given me the top number here as 10. So, to go from 2 to our 10, we've multiplied by 5. So if I want an equivalent fraction, basically what I have to do, I have to also multiply my bottom number by 5. So 3 times 5 gives me 15. And as you can see, I've multiplied that by 5. So what this is saying is 10 over 15 is equivalent to 2 over 3. I'll do another example. So we have 4 over 9 is equal to something over 36. Now, for us to get 36 from 9, basically I've multiplied 9 by 4. So if I want an equivalent fraction, all I have to do is multiply 4 by 4, which is going to give me 16. So I've multiplied by 4 to give me 16 over 36. So this fraction here is what we say is equivalent to that fraction, and both of these have the same numerical value. Okay, now example 2b2, they would like us to write each of the following fractions in simplest form. So basically this is going to be the opposite process. I'm looking for the highest common factor for these two numbers that I can divide them by, divide both the numerator and denominator to cancel out to give me the equivalent fraction in simplest form. So again, knowing your times tables is going to be useful here because I know that 7 is a factor of both 21 and 49. I can divide top and bottom by 7. So if I go 21 divided by 7 over 7, so I'm dividing the top number by 7 as well as the bottom number by 7. Basically what I'll be getting is, so 21 divided by 7 gives me 3 over, and 49 divided by 7 gives me 7. So 3 over 7 gives an equivalent fraction to 21 over 49, and you can always check if you've done it correctly, because if I multiply each of these numbers, numerator and denominator, by 7, I should go back to my original fraction. Now, in B, again, I have a fraction which I'd like to simplify. So basically, I want to try and simplify this 45 over 65. So what I'll do is, again, I'm looking for a number that I can divide both top and bottom by, which will allow me to simplify that fraction. So I'm quite confident that the highest common factor of 45 and 65 is 5. So if I divide 45 by 5 and 65 by 5, So 45 divided by 5 gives me 9, and 65 divided by 5 gives me 13, and of course I still have this 2 that needs to go in front. So I've been able to simplify that fraction by dividing both the top number and the bottom number by 5. Okay, in example 2b3, they would like us to determine which of those two fractions is larger. So basically what I would have to do, because we have different denominators in this situation, it makes it difficult to look at those two fractions and be able to determine which one's bigger or smaller. So to help me out, basically what I'm going to do is I'm going to find what we call a common denominator for those two fractions. So a way that I can help myself out is basically writing all the multiples of 5 and writing all the multiples of 7, and that will help me to find the lowest common denominator of the two. So multiples of 5 are 5, 10, 15, 20, 25, 30, and 35, and multiples of 7 are 7, 14, 21, 28, 35, 42. Now, I can see that both 5 and 7, one of their common multiples is 35. So basically what I'm going to do, I'm going to use that to basically find equivalent fractions for each of these, so such that their denominator is 35. So if I start off with the 3 over 5, so 3 over 5. Now, if I want my denominator to be 35, basically I need to determine what number I need to multiply top and bottom by to give me that 35. So in this situation, I know that 5 times 7 would give me 35. Now I can't just multiply at the bottom of a fraction by a number, I would have to also multiply the top. So 3 over 5 would become 21 over 35. So 21 over 35 is an equivalent fraction to 3 over 5. Now it might not be completely obvious yet why I've done that, but I'm going to do the same process for 4 over 7 to find an equivalent fraction with a denominator of 35, and then it's going to be a lot easier for me to determine which of those two fractions is larger. So if I have 4 over 7, and remember I want a denominator of 35, so basically to get 35 I know that I have to multiply 7 by 5, and again I can't just multiply the bottom of a fraction. Whatever I do at the bottom I also have to do at the top, so I'm going to multiply that by 5 also, and we'll see that my denominator is going to be 35, and 4 times 5 gives me 20, so the equivalent fraction for 4 over 7 is 20 over 35. So now, since we have these two equivalent fractions with the same denominator, it's much easier for us to compare which is larger. So we can see that 21 over 35, the numerator is larger, therefore this one is going to be larger than this one. So we can conclude that 3 over 5 is greater than 4 over 7. Therefore, 3 over 5 is larger than 4 over 7. And you can see if we didn't have the equivalent fraction, it wouldn't be very easy for us to make a comparison as to which of the two is larger.